everyone. In this video, we will do types of chemical reactions. The first is combination reaction. What is the meaning of combination? Yes, it is addition. So we will understand by the meaning of a word combination. Combination means when two or more reactants they are added to give me a single product. This type of reaction is known as combination reaction. Either two reactants are joining or adding to give me a single, or either three reactants, I can say, they will add together to give me a single product. The basic idea is that the product will be a single and reactants will be two or more reactants. So let's take an example. The first example I want to take, which is the same as given in your book, that example is calcium oxide plus water. It will give me calcium hydroxide plus heat. So now if I observe this equation, let's write the states first. This calcium oxide is in solid state, water is in liquid state, this is in aqueous state. So let's observe our chemical equation till here. I can see calcium oxide is plus water. Two reactants are there and they are giving me one single product, which means this is an example of combination reaction. But with this example, here mostly one question is asked on adding calcium oxide, which is also known as quicklime. On adding quicklime to water, we get slaked lime. Calcium hydroxide is also known as slaked lime. So what do we observe? So when quicklime is added to water, we are getting slaked lime. Along with the temperature, see I have written, along with this the temperature of this product will increase, which means it's giving me heat also. So this is the observation. On adding these two, my product will be heated, which means heat is released, and which is showing me when heat is released the reaction will be exothermic. So this is the most commonly asked question in the exam. What is the observation on adding quicklime with water? Now let's take another examples of combination reaction. So very simple examples we can take. Carbon plus oxygen. Carbon will react with oxygen, it will give us carbon dioxide. Again carbon is in solid form, oxygen is in gaseous form, and again carbon dioxide is a gas. Now I can see two reactants, carbon and oxygen, they are giving me one single product. Single product means, again this is an example of combination reaction. Let's take one more example. Hydrogen plus oxygen. Both are in gaseous state. They are giving me water, H2O. I'll just balance the equation. This is in liquid form. Again, two reactants are adding together to give me single product, which means this is an example of combination reaction. We can take so many examples, one or two I can take, which we have done at the starting of this chapter. Magnesium plus oxygen. See, if I am adding magnesium and oxygen, it's giving me magnesium oxide. Again, two reactants are adding together to give me single product. So all these examples were the examples of combination reaction, and in combination reaction I can see two or more products, they are adding together, they are combining together to give me a single product. The next one is decomposition reaction. So this word decomposition is suggesting me something which is breaking down. So let's Try to understand from the word itself. Decomposition means when a big compound or big product, big reactant, it will be broken down into smaller products. See, this time this is completely opposite of combination reactions. In combination, addition was taking place. Now in decomposition, the big product or the complex reactant, not product, this is the reactant, complex reactant, it will be broken down into two simpler products. So let's take an example. So the first example we will take calcium carbonate CaCO3. It will be, on providing it heat or on applying heat, it will be broken down into calcium oxide plus carbon dioxide. See, this is my complex reactant. When I am applying heat on this, it's getting broken down into two simpler products, calcium oxide and carbon dioxide. This calcium carbonate, it is also known as slag the lime. Calcium carbonate, it is also known as limestone. Limestone is marble. We use in our homes also marble. The same marble which is calcium carbonate, it is in solid state. Calcium oxide, this is quicklime. This is also in solid state, and carbon dioxide is in gaseous state. So let's take one more example. Now we will take example of ferrous sulfate. Again, on applying heat, it will be broken down into Fe2O3, ferric oxide plus sulfur dioxide plus sulfur trioxide. See, now my complex reactant, on applying heat, it's getting broken down into three simpler products. From here I can relate. Complex reactant is getting broken down into simple products. See, here reactants getting broken down on simple products, which means these are the examples of decomposition reaction. Let's take few more examples. Lead nitrate, on applying heat, it will be changed into lead oxide plus nitrogen dioxide plus oxygen. See, as of now I am not balancing the chemical equations. I am just trying to make you understand the concept, understand the meaning of decomposition reaction. Again, this is my complex compound or complex reactant on which I am applying heat, and it is getting broken down into three simpler products: lead oxide, nitrogen dioxide and oxygen. And in this equation or in this chemical reaction, sometimes they will ask what is the observation. So in this reaction, your observation is the formation of reddish brown fumes, which is showing me the presence of nitrogen dioxide. So let's take another example. Silver chloride, when it is kept in sunlight, see, in either way I have to provide some type of energy, either sunlight or heat. Only if I am applying some type of energy on this complex reactant, then only it will be broken down into simpler products. So on silver chloride we are applying sunlight. On sunlight it will be broken down into silver and chlorine. See, let's balance this equation also. If you want you can balance it, but as of now I am not balancing all the equations. You can see silver chloride, when kept in sunlight, it got broken down into two simpler products, silver and chloride. In this equation also, they'll ask you what is the observation. It's very simple. Your silver chloride, its color is silver. So when it's kept in sunlight, it will be changed into silver plus chlorine, and the color of the silver will be changed into grey. From silver to it will be changed into grey, and this is your observation. The same example we can take of silver bromide. When silver bromide is exposed to sunlight, it's giving me silver plus bromine. See, this is the reaction. Again, this is decomposition reaction. We can balance the equation, and for this type of chemical reaction, this is used in white and black photography. So this question can also be asked in the exam. So which thing is used in white and black photography? So that is silver bromide. Again, this is a decomposition reaction, and in the previous examples we have observed that we are giving heat. All the reactants are absorbing heat. So whenever the reactants they are absorbing heat, the types of reactions are known as endothermic reactions. Endothermic reactions. In the combination reaction, we have learnt about the exothermic reaction when the heat was released. In this case, the heat is getting absorbed. When heat is getting absorbed, the reaction is known as endothermic reaction. The next one is double displacement reaction. So this I will understand with this general form or standard form, when the reactants are in this form AB plus CD, and my B and D, they will just interchange the positions. See, they will interchange their positions, and I will get the products AD plus BC. Such type of reaction are known as displacement reactions. So let's try to understand with the help of example. I will take example of sodium sulfate plus barium chloride. It will give me, see, now the displacement of B and D will take place. So these two will interchange their positions. So I will get sodium, see, now chloride will come over here, or chlorine will come over here to give me sodium chloride, plus barium I will write as it is, and this sulfate will go over there to give me barium sulfate. See, I can see the reaction is similar to this, so I can conclude that this reaction is double displacement reaction. But here we will understand one more thing. This is aqueous. Barium chloride is also in aqueous form. Sodium chloride is also in aqueous form. But barium sulfate, it is insoluble white precipitate. Insoluble white precipitate means some white precipitates separately it can be seen apart from sodium chloride. And whenever precipitates are there, the types of reactions they are also known as precipitation reactions. Now let's take one more example. Now I will take another example, silver nitrate AgNO3 plus sodium chloride. Again, see, my reactants are in this form, A, B, C, I will write it D. See, these are in this form. Now this and this, they both will interchange their position. So in my products I will get silver chloride plus, see with silver chloride will come now, and with sodium nitrate will come. So I can see these two these two parts of my reactants, they are interchanging their position. So I got this thing which is in the form of AD and BC. This will conclude that this reaction is also an example of double displacement reaction. But again we have to understand one thing. This is in aqueous state. Again this is also in aqueous state. But this is insoluble white precipitate. This is in aqueous form. The formation of precipitate is showing me this is an example of precipitation reaction. The next reaction which we have to understand is redox reaction. Redox means where reduction and oxidation both has to take place. So before that we have to understand the meaning of oxidation and reduction. So let's start with oxidation. What is oxidation? Oxidation, it's suggesting me something which is related with oxygen. So I will memorize it by that way. So let's understand, if there is addition of oxygen in any reactant or any element, you can say, that reaction is known as oxidation reaction. Either there can be gain of oxygen, or it can be loss of hydrogen. So oxidation reactions are those, either one of the condition should be there in order to be an oxidation reaction. Either gain of oxygen should be there like this, or the removal of hydrogen should be there. So let's see the examples of oxidation reaction. Oxidation reaction means addition of oxygen. So let's react copper with oxygen. I'll get copper oxide. So let's balance the equation. Copper plus oxygen. I'm getting copper oxide. Addition of oxygen is there, which means this is an example of oxidation reaction, and this reaction will take place by the application of heat. So this example I can conclude my first type which I have studied is combination reaction. See, two reactants are getting combined to give me single product, which means this is an example of combination reaction also. This is an example of oxidation reaction also. And one last thing, these reactants, they are absorbing heat and giving me the product. The absorption of heat we have studied just now, that the absorption of heat means the reaction is known as endothermic reaction. So within one example I can conclude this is combination reaction also, this is endothermic reaction also, plus this is an example of oxidation reaction also. So let's take another example, and before that I want to tell you, like copper oxide, their states are, its state is solid, it is in gas state, and this is again in solid state, and the color of copper oxide is black. Now let's do with zinc. So if I add zinc with oxygen, it will give me zinc oxide. Again we have to apply heat. I can balance the equation also. See, this is a similar example which we have discussed previously. It can be oxidation reaction also, it can be combination reaction also, and it can be endothermic reaction also. So this was all about the oxidation reaction. Now let's study about the reduction reaction. Okay, before starting with reduction, we will take one more example of oxidation. Hydrogen sulfide plus chlorine is giving me HCl and sulfur. I can see from hydrogen sulfide to HCl, I can see here I have two atoms of hydrogen. Here I am left with only one, which means loss of hydrogen. Loss of hydrogen has taken place. And just now I have told you oxidation is either addition of oxygen or loss of hydrogen. In this reaction I can see loss of hydrogen is taking place, due to which this is also an example of oxidation reaction. Now let's start with the reduction. Let's understand the meaning of reduction reaction now. So reduction, this is completely opposite to oxidation. Oxidation was addition of oxygen, so reduction will be minus of oxygen. Minus of oxygen means loss of oxygen. And oxidation, it was gain of hydrogen. So this is any reactant. I can simply write it is loss of oxygen and gain of hydrogen. See, oxidation was gain of oxygen and loss of hydrogen, but reduction, it is opposite here. There will be loss of oxygen and gain of hydrogen. Let's understand it with the help of examples. So we got copper oxide. We'll pass copper oxide from hydrogen gas and we will get water, H2O plus copper. This is in solid form, gas, liquid, again solid. If you see from copper oxide to copper, here oxygen was there, now only copper, which means loss of oxygen has taken place, and loss of oxygen means reduction reaction. Let's take another example. When H2 hydrogen and C2 chlorine, they are reacting together, I am getting HCl. I am getting HCl. It is in gas form, it is also in gas form. So this is in aqueous form. Now you can see in chlorine there is addition of hydrogen, and addition of hydrogen means the reaction is reduction reaction. Now since we have understood the meaning of oxidation and reduction, let's try to understand the meaning of redox reaction. Redox means where both oxidation and reduction is taking place, in which both reduction, red means reduction, ox means oxidation. So such reaction in which both reduction and oxidation is taking place. The meaning of reduction and oxidation just now we have discussed. Now let's find out such reactions in which both of these processes are taking place. So let's take one example. Let's take hydrogen sulfide. When it's reacting with chlorine, it's giving me HCl plus sulfur. Now I can see if I go from H2S to S, I can see loss of hydrogen. See, here it was H2S, now I am left with only S, which means loss of hydrogen has taken place, and loss of hydrogen means oxidation. We have discussed either gain of oxygen or loss of hydrogen is an oxidation. Now let's see this. If I go from chlorine to HCl, I can see an H atom has been added, which means hydrogen is gained or added. Hydrogen is gained in chlorine. And just now we have discussed, if hydrogen is gained, that process is known as reduction. And now you can see in the given example, both oxidation and reduction is taking place. If both oxidation and reduction is taking place in a chemical reaction, this means the given reaction is redox reaction. Let's take another example. Copper oxide when copper oxide reacts with hydrogen, it will give me water plus copper. See, copper oxide plus hydrogen, it's giving me water plus copper. Now I see from copper oxide to copper. See, here oxygen was there. Here only copper is there, which means loss of oxygen has taken place, and loss of oxygen means reduction. See, gain of oxygen is oxidation, loss of oxygen is reduction. Now let's see from H2 to H2O. So here I can see oxygen has been added. Oxygen is gained or added. And gain of oxygen is, I know it is oxidation. Again, in the given reaction, I can see both reduction and oxidation is taking place, due to which I can conclude that the given reaction is redox reaction. So now I have given you one example. Now you have to see which type of reaction is this. I want you to try this, and you can also comment in the comment section which type of reaction is this. And with this, a types of reaction is finished. Thank you so much for watching the video.